Yeah, I can.
You can see me? Okay, great. So welcome everyone. And I'm speaking to the camera as well as those in the room. We're very excited to present as far as the 2025 Gothic Research Seminar Series. We have two gentlemen from South Korea who are doctoral candidates that are here to present their research. And we're very excited. And I think they'll agree. I hope you don't mind as we go along to if we ask questions. And I know you have a lot of material to go through, but hopefully this is we have some interactivity here and can get some great discussions going. I am Professor Cotillo, and just introducing myself, we have a few other professors here in the audience. However, I don't think the cameras can reach out into the audience, so I'm just will tell you everyone's here with smiles on their face and looking forward to this presentation. As far as introductions for the two speakers, I will let you both, I assume, kick off. As far as I'm not sure who is which one we're doing first here. Oh, a conjoint analysis model with attribute groups focused on SmartWatch. Um, so looking forward to it. If you could come on up and make sure that I guess, if you can try to get into the range of the camera. For those on Zoom, if you have a question, please speak up and put it in the chat. I'm not sure if we're going to be able to hear you here. And so, as a courtesy to the speaker to make sure that it's clear, it might also help that if it was typed out and correct. Great. Great. So I'm going to turn it over and
Okay. Good afternoon. My name is Sangwon from Korea University from South Korea. First of all, as a PhD candidate, you are very honored to present my present research from all of you at the NDCU Gothic Research Seminar Series. I know that this is not a common opportunity, so I'll do my best for today's presentation. Today, I prepared about the newly developed conjoint analysis model based on the concept of the attribute groups and its application to SmartWatch. Okay. But first, I want to briefly introduce myself. I'm currently a PhD candidate at Logistics Service and Operations Management Department in the Korea University Business School. From now, I will show for LSOL as my department. And starting from 17 to 19, I also pursue my MS degree at the same department at the Korea University Business School. And from the third, as you can see, it has a blank three years before I pursued PhD. Can you guess what I did at that moment? In Korea, we had to do military service. So I pursued my military service at the Republic of Korea Air Force. So I was an airman at this period. So my research interest covers of the development of the sustainable product or service based on some empirical, both and mathematical concepts. Also, I'm also interested in the derive of the operational strategies via using the optimization models. And as I recently published of the paper about the concept of the customer's value co-creation and platform's network effect on the service quality and customers' loyalty with using the car-hailing service data in China with my co-workers. And additionally, I also published about the using the context of the user experience service and TV home shopping mobile application. In addition, I also developed some EA AR model with some weight bound using the triangular distribution as my MS thesis and its application to the productivity of the domestic kindergarten using this model. And I currently have some working paper. Recently, I have some minor revision about using the Korean kindergarten, using EDA to compute some productivity before and after COVID-19 pandemic. In addition, second one, which will be the present today, is currently in preparation of manuscript for initial submission, and also I conduct the conjoint analysis to design some service, especially futuristic autonomous tech service, as most of you will be known this service as Tesla's global taxi. So let's move on to today's topic. First, what is conjoint analysis? The conjoint model is a method for design, product, and service to maximize the expected customer's utility. How? The hypothetical profit part is presented to respondent, then respondents see the set of the profit part and rate their preference based on the Likert scale or choosing experiment. Then analyze the relative preference for each attribute through dummy regression. This is the example of the profit card. As you can see, the two profit cards consist of each attribute and some specification. I will call this specification as the level from now.
Yes, to be in the camera.
Yeah, I will keep it here. Okay, this is the one question. Among these two profit cards, as you are the customer, which profit cards are rating you can rate the more easier, left one or right one?
As a customer?
Yes, as customer.
Left just looks simpler.
Yeah. I also agree on the left side. The one reason that left side only consists of the 3 attributes, while right one has a 5 attribute. So the computing the trade-off between these attributes is more simpler is the left one. So this is the traditional.
But do you lose anything? Being from it sounds like a trade-off, correct? And maybe I'm front running what you're going to talk about, but just compared to it's simpler. Or are we missing anything on the right?
Yes. The simple profit cost has a risk to lose some important information about the trade-off, but this is the traditional problems of handling the large numbers of the attribute in conjoint model. As the number of the attribute in the conjoint model increases, more parameters and data are required to estimate the patois, which is the relative importance or preference of the attribute and its level. But considering massive number of the attributes may cause the consumer the information overload, which is the computing too much trade-offs. However, there is a recent trend suggests the more comprehensive approach that incorporates both functional and emotional dimensions. So there is a significant increase in the number of the attributes that consumer consider when assessing the value of the product. So this raising concern is the major motivation to researcher to develop the model with the large numbers of the attribute. The recent model has the trend consists of three categories. The first one is the self-explicated method. This one directly asks the consumer about their relative importance of the attribute. But this model cannot be efficiently compute some trade-off between the attributes. The second one is about the method for dividing massive number of the attributes for the several groups. Suppose we consider 15 attributes. In this case, divide the 15 attributes with the 3 groups. Suppose 3 groups, then with the 5 attributes each. Then perform conjoint analysis for each group independently, then synthesize the result. The final one is about the partial profit method. This conduct a survey using the only subset of the attribute under the consideration. So fewer profit cards are required because we doesn't consider some of the attribute, but we cannot compute the relative weight of attribute which does not appear in the profit card. So each model has some pros and cons. So in the proposed model, our model follows the second string, which is all attributes are divided into attribute groups and synthesize the result. But today's model has some difference because our calculator is adapted more efficient to derive the derive the patterns of each attribute. So let's move on step by step, but this is the mathematical notation. So this part I will keep in fast pace. First step is about the define some elements to require our model. First, we have the attribute group, and each attribute group has some attribute D. And each attribute D has some labels, which is specification about delta. And combining each attribute label, we generate some profile set. We say that each profile has the HK. Then participants are coming to rate their preference will be noted as a psi for each profile set. Then we conduct some OLS estimation to compute the patterns of each attribute for each group using the OLS estimation. But unlike the traditional model, we divide all the attributes for the several groups, then synthesize. So we have to, this model does not guarantee that all the result is on the same scale, which is called a scale effect. So the traditional models use the additional experiment procedure, calling the bridging experiment. But our model does not require the bridging experiment. Instead, we use some common attribute for all attribute groups. In this case, we use the attribute price. Then using the attribute group's price patterns using the following linearization process, which is called White-Dwarf's linearization model. Then the patterns of the attribute with each group are standardized based on the patterns of the price. Then enable comparison across the different attributes because we in the different scale to the same scale. Now the patterns are standardized. We can compute the expected utility for each profile using the simple linear combination approach and the relative weight using the size of the range. Let's move on to the first question. What is the objective of our model? The objective of our model is to compute the massive number of the attributes while minimizing the information overload problems. So the question is our model really can get an equivalent result while considering massive number of the attributes at the same time? The answer is yes. This is about the proposition 1. While we prove this proposition using the mathematical model, but due to the time constraint, I will skip this part. But if you have any interest, please let me know. I already prepared all procedure as the appendix. I will show you later. Now, the theory part is over, and let's move on to the application part. First, why smartwatch? As you can see the left graph, the global smartwatch market revenue increased from about double times, 2 times for the 5 years, from 2019 to 2024. However, as you can see the right graph, at the same time, competition in this market is also increasing, especially the rising of the Chinese brand. So each brand tried to develop the technological level of each attribute, but due to the limit of the resource, not all the attributes can be improved at the same time. So this dilemma is the major motivation to our research to apply this model to design of a smartwatch. First, we have to define some attribute groups and corresponding attributes. So to define this attribute, we conducted the text mining approach to effectively consider the voice of the customer. So we used the Amazon customer review data, and it consists of more than 18,000 reviews with the 8 major brands. And I conducted the text analysis using the R. And let's start by looking at some two diagrams. As you can see, the keyword like the track, battery, run, hot, charge is the most occurred nouns, more occurred keyword, and interconnected each other. In addition, we're using the topic modeling by setting the number of the topic as the 4. As you can see, some different keywords are located at the different topics. So based on result, we conducted some expert interviews with some SmartWatch developer in the industry. So based on their feedback and comment, we finally defined the 4 attribute group as follows. The first one is about the hardware of the smartwatch, and second one is the healthcare function, and third one is the fitness tracking function, and last one is the customer service by the brand perspective. And as you can see, the major keyword for each attribute group is as follows. So based on that, for each group, we set the attribute as follows. As you can see, the common attribute price is located at all attribute groups. And we surveyed the data from the Korea University Business School student. And our survey procedure consists of the 3 major parts. First one is the self-explanatory test, which is the directly ask their relative importance of the attribute group level and individual attribute level. Then we define the 4 attribute groups. So we prepare 4 sets of the profile card set, then present to the consumer and rating their preference. Then we use the hold-up sampling. I will talk about the hold-up sampling later, but briefly say the hold-up sampling is about the present some profile card and the no choice option, then ask consumer to choose one of them of the most preferred one. This is to estimate the expected validity of our model. Then the result will be shown later. So let's move on to the major result. First of all, when analyzing the relative rankings, importance ranking of the 19 attributes in our model, it highlights the importance of the competitive pricing, then measure the blood sugar by using non-invasively, just using watch, and compact size for designing the competitive smartwatch. And our model is the newly developed model, so we have to test our model is valid or not. So the estimated attribute weight must accurately reflect the respondent's perceived one. So we ask the respondent about their their relative importance by the first phase of our survey. So using this vector and estimated weight vector compared using the Wilcoxon side length test, and results show that no statistically significant difference between the 2 vectors. It indicates that our model can accurately reflect the respondent's preference. In addition, we hold the hold-up validation. The hold-up validation results show that about our model's average prediction rate accuracy is about the 52.88%, about 2.1 times greater than the random choice probability. We propose the 3 profile cards and no choice option. So the probability of the random choice and correct is the 25%. So our model is about 2 times greater than the random choice probability model. And among all participants, about 77% of the participants demonstrate the hit rate exceeding the random probability. So it indicates that our estimated weight reliably reflects their actual preference. Finally, we have conducted some market segmentation analysis. To perform the market segmentation analysis, we have to define the number of the segments. So to do this, we performed some elbow method and silhouette procedure, silhouette score. Both of them suggest the 4 group is appropriate, but our data only consists of the 113. So 4 groups cannot, each group, the members will be relatively small. So we choose the 3 groups. And using the k-means clustering result, the result is as follows. And as you can see in this graph, even for the same attribute, the preference structure for each cluster is different. In more detail, the cluster 1 mainly prioritize about some hardware attributes, such as size, weight, and the charging speed, while second group emphasize the healthcare function, while the last group place the greater importance on only price. So let's move on to our final conclusion. First, let's summarize the key finding. First, our study developed a new conjoint model that addressed the limitation of the traditional models. Especially the traditional model faced some challenges such as the respondent information overload when dealing the large numbers of the attribute, but our model can effectively reduce such an information overload. And second one, for practical implication, our study reveals that maintaining competitiveness in the smartwatch industry requires some segment-specific smartwatch design, not just a one-size-fits-all approach. But our research also has some true limitation and some direction. First, our study mainly collect the data from the students, so it may be insufficient to represent the preference of all the demographic structure. And second one, while this study identified the key attributes and its levels using the conjoint analysis, but it does not identify the optimal position for new smartwatch to enter the market because the conjoint model does not consider the competition between the firms. So the future research should focus on determining some optimal position for launching the new smartwatch based on this result. Okay, this is the end of my presentation. Thank you for listening.